So the first thing to notice about this particular function is that it is not a polynomial, and that is because of the fact that you have this negative exponent. So the negative exponent means it's not a polynomial, so it will not be continuous for all real numbers. Now, the key thing to remember about these negative exponents is we really don't know how to deal with them unless we get rid of them. And the way we get rid of a negative exponent, of course, is to move it to the denominator where it will change signs. So the first thing I'm going to do here is I'm not going to start thinking about continuity. I'm going to think about the negative exponent and rewrite this as 1 over t plus 1. Please note, when you look at the original function, you have two terms here. Remember, terms are separated by an addition sign. So you will have two terms when you move the negative exponent down to the denominator, and you'll have 1 over t and then plus 1. All right, so now we can answer the question of continuity. So again, remember that for if the function is continuous, we are focusing mostly on three potential problem spots: piecewise, fraction, or square roots. And here we have a fraction, so we know that this function will be continuous provided that the denominator is not equal to 0. Well, in this situation, our denominator is t, so it will be continuous provided that t is not equal to 0. Now, once we have where it is continuous, our next step is going to be to answer, of course, the question of what type of discontinuity we are looking at here. So in this particular case, we say to ourselves, because we have a fraction, we want to see if that fraction is removed or canceled. So remember that the question for types of discontinuities with fractions are, can the denominator cancel or is the denominator left over? Now, when you look at your function here, g of t, there's no way to cancel out that t denominator with something in the numerator. So because of the fact that the denominator is left over, it does not cancel. So it doesn't cancel, it's not removed. Because of that, so it's left over, it's not canceled, it's not removed, that means that the t is equal to 0 is a non-removable discontinuity. And as we talked about, in order to have a non-removable discontinuity, you basically have a vertical asymptote. So another way of saying this is that we have an infinite discontinuity at t is equal to 0. So the function is not continuous at t is equal to 0, and we have an infinite discontinuity there.